Hello, welcome. Today we are talking about secant lines and circles. So we're sort of continuing with where we left off. So previously we discussed tangent lines, which are lines that touch the circle on the outside but do not cross through it. Secant lines intersect the circle at exactly 2 points, which means that our secant lines will cross through the circle instead of simply brushing up against it on the outside. So most of the things we're going to be looking at today are the relationships between the angles and arcs formed by these secant lines. And there's basically 3 different cases that we're going to look at. The first one tells us what happens when the secant lines intersect inside the circle. So we notice it's basically just like any intersecting lines. We have angle pairs that are formed. And if you notice, we also have arcs that are formed by the points on the line that intersect with the circle. So in our first case, the angles formed are inside the circle. And when that happens, the measure of the angle is 1/2 of the sum of the 2 arcs. Or another way to think of it is the average of the 2 arcs. So in the picture that's drawn, if I wanted to find the measure of angle 1, I would add arcs AB and DC, then divide by 2. If I wanted to find angle 2, I would add arcs AD and BC, then divide by 2. So here, if I'm looking for angle X, I notice that X intercepts arc UT, and on the other side it intersects arc RS. So the measure of the angle will be 1/2 of the sum of the arcs. So we simply add the arcs together, divide the answer by 2. We get 107 degrees. Part B, again we're looking for X, so this time we're looking for the angle at point E. If we trace the angle, we notice that it intercepts arc BD, and its vertical pair angle intersects arc AC. Unfortunately, neither of those are filled in. However, we do know the values of arc CD and arc AB. So if I take 1/2 of 143 plus 75, I get 109 degrees. So the 109 degrees is not our X value, but it is adjacent to our X value. Right? So it goes inside of the 2 arcs that were intercepted. And I could put it on the side I did. I could put it across from there. It doesn't matter, right? Remember, vertical angles are congruent. I noticed that the 109 and the X form a linear pair. Therefore, the X and the 109 should add up to 180. So X is going to be 71 degrees. For part C, this time the X is on our arc. So we're going to use the same rule, only the setup is going to get plugged in slightly differently. So the 110 is our angle, and that equals 1/2 of the sum of the arcs. Notice here we just have an equation to solve. We're basically working the equation backwards from before. So if we have 1/2 on the right side, the opposite of that is multiplying by 2. So if x plus 97 equals 220, subtract to solve for x. So we get 123 degrees. All right, so the next theorem is what happens when the vertex of the angle is on the circle. And so in our video on inscribed angles, we said that if the vertex of an angle lies on the circle, its measure is half the intercepted arc. Well, this is no different, right? So the rule for this is the same rule that we used before. Right, so if x is the arc, the angle is half. So when we look at our diagrams, we notice that we are looking for the angle QPR. Point P is on the circle, and the intersected arc is 148 degrees. So the measure of the angle is equal to 1/2 the measure of the arc. Part B, we're looking for the arc from D to E to F. Again, we pay attention to the letters. We go around in the order that it's given. And since they put the little curve on top of our letters, it's telling us to trace around the circle. We notice they gave us an angle marked 64 degrees. However, the arc for that angle, the intercepted arc, is the arc from D to F. So if I'm using the rule we looked at in the previous example, I'm actually solving for DF. Right? So the measure of the angle is equal to 1/2 the measure of the arc solve, right, work it backwards. So we know the measure from arc DF is 128 degrees. I notice that if I combine the arc from DF with the arc DEF, it forms a complete circle. So that means that those two arcs should add up to 360 degrees. So the measure of DEF plus the 128 degrees that I just got should equal to 360. So the measure of DEF should equal 232 degrees. So finally, if the angle is outside the circle, if the two lines intersect outside the circle, we're going to take 1/2 of the large arc minus the small arc. So if the angles are inside the circle, we add. If the angles are outside of the circle, we subtract. So I'm looking for angle L. Notice L hits the circle at H and K, and so there's our two arcs. However, I notice only one arc is labeled. So I'm going to have to figure out the arc from JHK. So if I take 360 subtract out the 102, tells me 258 degrees goes here. Since angle L is outside the circle, the measure of the angle is 1/2 of the big arc minus the small arc. So angle L equals 78 degrees. All right, so this time we're looking for the arc from C to D. Again, the angle's on the outside. So the angle equals 1/2 of the big arc minus the little arc. And be careful here, right? The order that you place these matters. The larger number always goes first. So we double both sides to get rid of the 1/2. The missing arc is 207 degrees. In our last example, we've got 128 here, 84 degrees here. The angle is on the outside, so angle D is equal to 1/2 of 128 minus 84. Which equals 22 degrees. That's all we have for today. I'll see you next time.